Hello scholars! Today's video lesson is about the perpendicular bisector of a segment. We will illustrate this concept and later on solve some problems that are related to it. For this to be easily understood, let us use an analogy. Let's say there are two schools, PSHS ABC and MCSHS, on both ends of a straight road. The jeepney drivers catering to the needs of the students and teachers of these schools cannot come to the road joining them, so they decided to stop at any point that is equidistant or of equal distance to both schools for fairness sake. But where are those points located? Let us help them solve their problem. How would we find that path? The word equidistant gives us a hint that it should pass through the midpoint of the segment joining PSHS-ABC and MCSHS. So we found that here on point C. Is it enough to just let any random line pass through the midpoint C? Well, we said that the condition should be it should be equidistant to the points A and B. If we consider the first line, at some point in time, the jeepney would be closer to point A and farther from point B. In the second line, it would be the opposite. So how would we find the line that would make the jeepney of equal distance from both A and B? Let us try to draw a line passing through C that is also perpendicular to segment AB. Now, let us let any point F along that perpendicular line to represent the jeepney going to both schools. In this GeoGebra animation, we could see that at any point along that perpendicular line, the distances between the jeepney and the two schools are equal. This now solves our problem. Now, we actually have a specific term for line FC. First, we know that it is perpendicular to segment AB. Second, we know that since it passes through the midpoint C, it actually bisects AB. Thus, we call FC the perpendicular bisector of AB. Let us now formally define the perpendicular bisector of a segment. It is a segment that divides a segment into two congruent segments and is perpendicular to it. Now let us solve some problems applying our knowledge of the perpendicular bisector of a segment. In this figure, FC is the perpendicular bisector of segment AB. If AC is equal to 2.7, what is BC? Now we know that since FC is the perpendicular of AB, it bisects AB into two congruent segments. Therefore, we could say that AC is actually equal to BC. And because AC is equal to 2.7, therefore BC is also equal to 2.7. In the same problem, if BC is equal to 1.9, what is AB? Now we know that AB is actually twice of BC. Therefore, AB will be equal to 2 times 1.9. And simplifying that, we get AB is equal to 3.8. Let's have some angles too. So for the same problem, what's the measure of angle FCB? Now we know that angle FCB is the angle formed between the perpendicular bisector and the segment AB. Therefore, since they are perpendicular, we know that simply the measure of angle FCB is 90 degrees. Let's have one more. If BF is equal to 29, what is AF? Now we know that BF and AF are segments joining the endpoint A and B of the segment AB to a point F which lies along the perpendicular bisector of the segment AB. Therefore, we know that this point is actually equidistant from points A and B. Therefore, if BF is 29, then BF would be equal to AF, which is also 29. That solves our problem, and we know that AF is equal to 29 units. Let's have one last. If angle HCF is equal to 29 degrees, what is angle ACH? Now we know again that FC is the perpendicular bisector of segment AB and thus forms a right angle. Now, since they are right angle and angle HCF and angle ACH are parts of that, 90-degree angle, therefore we could say they are complementary. And since they're complementary, they add up to 90 degrees. Therefore, we know that angle ACH is equal to 90 degrees minus angle HCF. Therefore, we would have 90 degrees minus 29 degrees, which gives us angle ACH is now equal to 61 degrees. I used the GeoGebra app extensively in this video to draw my illustrations. Therefore, I would like to thank the developers of this app.